This time, I'm going to talk about reinforcement QLearning in Python. QLearning is one type of reinforcement learning. It is an off-policy reinforcement learning algorithm that seeks to find the best action to take given the current state. If we have an agent, and the agent is in certain environment, and if the agent takes certain action, it might change the agent's state from one state to another one. And based on the agent's action and the change of the states, it will get reward or penalty from the environment. If there is a dog in your house, the dog is the agent, and the house and you are the environment to the agent, that is, to the dog. And if you want to train the dog to sit or to stand, you want to change the states of the dog from standing to sitting, or from sitting to standing. And based on if the dog can take the correct action to your command, you give your dog a reward or penalty. And over time, the agent, your dog, will learn how to act correctly to your command. That is the basic idea of QLearning. Now, let's try to solve this problem. There is an area here, and you are driving a cab here. And there are 4 spots. You can either pick up a customer or drop off a customer. That is, this R, G, B, Y is the only spot you can pick up a customer or drop off a customer. And there is a wall here, so the taxi cannot cross this wall. And also there is a wall here. And our task is to pick up a customer from Y and drop off the customer to R. We can take 6 actions here when we drive the taxi. That is, we can go either south or north or east or west, or pick up a customer or drop off a customer. Now, let's think about this situation. The taxi is at this spot right now. The taxi can go forward or go back or go to the right, but it cannot go to left. So when the taxi is trying to go left, the taxi driver will get a penalty. Now, we want to build our QLearning model to help taxi driver increase his efficiency. Fortunately, there is a package in Python called OpenAI Gym has this self-driving cab environment already built for us. So if you import this gym package and build this environment, every time if you call this inf.reset, it will generate this environment with the taxi at a random spot in this area. As I mentioned, the R, G, Y, B are all those locations. You can either pick up a customer or drop off a customer. Now, let's talk about Q and QTable in QLearning. The Q in QLearning stands for quality. When QLearning is performed, we create what is called a QTable, or matrix that follows the shapes of state and action. That is saying, at a certain time, we are at certain state, and from that state, we are going to take certain action. And because of that action, we are going to change our state to a new state. And from the new state, we are going to take next action. At the beginning, we initialize our value to 0. And then we will update and store our Q values after an episode. The episode in this example means when we deliver a customer. So this Q table becomes a reference table for our agent to select the best action based on the Q value. At the beginning, because the Q value are all 0, so our agents just take random actions. But over this QLearning process, our agent will become smarter and smarter. These are steps for updating the Q table. First, agent start in a state, takes an action, and receive a reward or penalty. Then, agent select action by referencing Q table with highest value or by random. That means at the beginning, we just take a random step, and later, to a certain percentage, we take random step. To certain percentage, we will reference the Q table, takes our best action for the next step. After that, we are going to update Q values. If we view our Python code, will be something like this. Let me explain gamma first. Gamma is a discount factor. It is used to balance immediate and future reward. For example, if we take 0.5 as our gamma, that means for the next max, we only consider half of it. That is, we apply the discount to the future reward. What is alpha? Alpha, also called the learning rate, can simply be defined as how much you accept the new value versus the old value. In this formula, if the old value is here, then we will consider 1 minus alpha to the old value. That means the weight of the old value is 1 minus alpha. And the second item will have weight of alpha. So the whole process will be, we will take the old value and then we try to get the next max based on the next state, and then we will have our weight to the old value and this reward and next max to calculate the new value, and then we will update the Q table. So at the beginning, the Q table will reset to all 0. There's no information here. So our agent will take a random move at the very beginning. And after the training, we are going to update the Q table. This is actions we have, As I mentioned, we have 6 possible actions. This is 4 directions the taxi can move. This is pick up, this is drop off. And we have all those states here. Now, let's take a look at this state. We are going to take the maximum value to decide our next best move. Among those 6 numbers, the minus 1.97 is the largest one. So, our best action at this state should be driving north. And how about at this state? If we compare all those 6 numbers, the largest number is 29. So our best action should be driving west. That's how we use this updated QTable. Now let's go to Python, see how can we implement our QLearning algorithm. First, let's take a look what will happen if we don't use QLearning. First, we will import Gym, the package, and then we are going to initialize it. Of course, at the beginning, the penalty and the reward are all 0, and then we just take some random actions. Let's run the program. You can see now it's already over 600 steps. 800 steps. Okay. The action our program takes 899 time steps, and the penalty happened 297. This is what happened when we don't use QLearning, and eventually it pick up a customer and drop off a customer, but it has a lot of penalties here and takes almost 900 steps. Of course, if you run this program again, it will give you a different number. Okay, now let's use QLearning. First, we are going to initialize our program, and then we are going to use 50,000 training episode to train our model. And after that, we are going to try to deliver the customer 400 times. Now, let's run the program. As I mentioned, at the beginning, the QTable are all 0. And then, for one customer, we call it one episode. So, this is 1000. We are going to use 50,000 training. Now it's 40,000. Okay, we finished 50,000 training. And then you see the QTable value, right? Changed to this value. Comparing with the beginning, it's all 0. The average timestamps per episode after the QLearning is about 13 steps, and you can see the penalties per episode is 0, so no penalty after the QLearning. Remember, before the training, the timestamps we need is about 800, and now we have 13, and the penalty dropped to 0, comparing the penalty was about 300. So this is the power of QLearning. After the training, we can deliver our customers more quickly, more efficiently. This is my explanation about reinforcement QLearning and how we can implement that in Python. Please provide your comments and subscribe to my YouTube channel. Thank you.